Good morning, Phoenix class, and welcome to today's maths lesson. I can find the area of triangles. So the most important thing to remember that we've already learned is that two identical triangles can fit together to form a rectangle. If you can remember that, that will really help you in today's lesson. So our first question, we've got two triangles that are drawn there. And the lady says, I wonder what the area of the triangle is. So the question is, work out the area of Andy's triangle. So why is it sometimes good to estimate and not calculate? Because it's nice and quick, isn't it? And we've got to think about today how those squares can actually help us estimate the area of the triangles. Could we turn it into a rectangle? Would that help us? Let's have a look. We've got three whole squares there, or more or less whole. Wonder if we've got any part squares that would help us. We've got two there. They're like half squares, aren't they? So that would make us four. Would any of the others fit together? Well, those two look like they're about 3/4 of a square. And those little ones probably would fill those up. So we've got three holes, two halves, so that's four holes. And then those last green ones, we can make that into two. So maybe we could estimate that the triangle, is 6 centimetres squared. There's another way we could do that as well. If we look on method 2 here, if we got our scissors out and we chopped our triangle apart, we could move different bits of our triangle so we could make it into a rectangle. If you follow those arrows and move that part of the triangle to where the arrow ends up, you can see that we can make a rectangle. If you drew out yourself some squared paper at home, draw that triangle and have a go at cutting it, because it's certainly much easier to understand once you've had a chance to cut one up yourself. Remember, you can pause the video and come back to it after you've had a go. Now, we want to look at the other triangle. What's the area of Jamie's triangle? Well, this one is a bit different. I think this is easier to do in some ways because you can see that her triangle is actually an isosceles triangle. Therefore, we can chop it down the middle. So if we cut it down on that red line, all we need to do is take one half and turn it over and fit it back together, and suddenly we've made ourselves a rectangle. Now we know how to find the area of a rectangle. We need to remember that to find the area, we times the length by the width. So the length here is 3 centimetres and the width is 4. So we can times those together and that will give us 12 centimetres squared. What about this one? Now, this question is asking us to estimate the areas of the triangles. So we're not trying to calculate it, we're trying to have an educated guess. So as you can see on A, I've started to count the whole squares. So I've got 1, 2, 3, 4, 5 whole squares. Now I'm going to have a look at my half squares. I've got 8 half squares. So 8 half squares, that's going to be 4 whole squares, roughly. Remember, this is only an estimate. Now I can see that I've got some that are nearly whole squares. Not quite though. So how many of those have I got? I've got 3 nearly whole squares. I have got some other bits left over as well, but I'm just going to ignore those for the moment because this is an estimate after all. So I can then add up my halves, my wholes, and my nearly wholes. And if I add all those together, I can estimate that that triangle has an area of 12 centimetres squared. So I want you to have a go at this next one. Remember, you can keep pausing the video so that you're working along with me. So first of all, can you count the number of whole squares? As I say, pause the video and count them for me. Right, you've got your whole squares. Now I want you to count the almost whole squares. So they're more than half, but not quite whole. How many of those have you got? And now I want you to count the half squares. Right, so you should know now how many whole squares, how many almost whole, and how many half squares. The little bits that are left over, I want you to ignore. Can you add all of those up for me? You can check your answers on your PowerPoint. Okay, what about this one? So here it's asking us to find the areas of the following triangles by making rectangles. So this time we want to think about how we're going to cut our triangle up. So if we have a look at A first of all, we can cut our triangle by cutting along that red line. And then we want to make our top parts of our triangle join the bottom part to see if we can make a rectangle. So first of all, I'm going to take this bit and I'm going to move it so it fills in the rest of that square there. Can you guess what I'm going to do next? Well, next, I'm going to take this bit and I'm going to move that and I'm going to make that fill the other part of that square. So now I've formed a rectangle which is 1 centimetre by 3 centimetres. So I can now work the area of that rectangle out, which of course will give me the area of the triangle. If we look at B, so again, we're lucky that this is an isosceles triangle. So this time I'm going to cut it straight down the middle. We can now move one half of our triangle next to the other half of the triangle, like that. So again, we've formed a rectangle. You know how to work out the area of the rectangle. It's the length times the width. So I will leave that one for you to do. Okay, let's go into our practice book and have a look and see what we're doing here. So if we read question 1, it's asking us to calculate the area of each triangle by turning it into a rectangle. So you need to think about where you're going to cut your triangle and then where the rectangle is going to be formed. So in A, we're going to cut it down the centre and we're going to move one side over to the other. And I've drawn in your new rectangle. So on B, this time we're going to cut those grey bits off. And again, we're going to move those round to make the rectangle. So your new rectangle will be there. And on C, now this one's a bit tricky because the triangle has been drawn at an angle, but actually we're just doing the same thing. It's an isosceles triangle, so we are going to cut it down on that line and we're going to move one part over to form the rectangle. On question 2, now this is asking you to estimate the area. So remember, count the whole squares, count the almost whole squares, and count the half squares. Add all those together, ignore the little bits. And then on question 3, you can see there I've marked where you're going to cut this triangle. So you need to cut the triangle there to form the rectangle. Number 4, is it always sometimes true or never true? So this is where you need to prove by drawing pictures and drawing diagrams to help you answer the question. And finally, triangle A has an area of 6 centimetres squared. Jess thinks that the area of triangle B is twice the area of triangle A. Is she correct? So what you have to do with this one is find the area of triangle B. Is it double the area of A? If you fancy more practice, you've got some other ones there. If you want to do the challenge, that's there as well. And then finally, you've finished by doing the reflection. So this is basically summing up your learning. Explain how to find the area of a triangle in 2 different ways. Well, we've been practicing finding it by counting the squares and half squares and almost squares. And we've been practicing finding it by turning it into a rectangle. Good luck today. Bye.